Hello, this video is about section 6.1 and 6.2 in your MyLabs Plus homework assignments. I'm going to go pretty fast through this, and you can pause between every frame if you want and take notes or absorb what I'm saying. It's about adding and subtracting fractions. First of all, how many pieces is this mushroom divided into? 1, 2, 3, 4, 5, 6, 7, 8 pieces. So the total is 8. The total always goes on the bottom, the total number of pieces. How many pieces have mushrooms? 1, 2, 3, 4, 5, 6. So 6 out of 8 pieces have mushrooms. 6 out of 8, 6/8. We can divide the top and the bottom by 2. So really it looks like 3/4 of the pizza has mushrooms. 3/4 is the reduced and better looking answer. 6/8 is right, but 3/4 is better looking answer. A fraction is made up of a numerator on top, denominator on the bottom. The bottom is always the total things that you're considering, and the numerator is all the good things, or all the things you care about, like mushrooms in the last question. The next picture is of gears. Count the total gears. The total gears is 1, 2, 3, 4, 5, 6 gears, but how many are purple? I know the contrast isn't very well, so I'll tell you 1, 2, 3, 4, 5 of the gears are purple. So the denominator is how many parts it's divided into. We have 6 different pieces. And the numerator is how many parts are being considered, in this case purple. 5/6 of the gears are purple. There's 4 ways to consider fractions. I'm going to go through each one now. The first way to consider fractions is colored regions. How many regions of this circle are there? Well, it's divided into 4 regions. That's my total. And how many are light blue? 1. That means 1/4 of the circle is light blue. I could ask the question, how much is darker blue? There'd still be 4 pieces, and 3 of them are darker blue. So 3/4 of the circle is dark blue. In the next colored regions example, we have rectangles. How many rectangles total? 12. How many are darker blue? 4. So 4/12 of the entire shape are colored dark blue. And 4/12 can be reduced because the top and the bottom can be divided by the same number. That's how you reduce a fraction, dividing the top and the bottom by the same number. So we could divide this into 3 different regions. 4 squares, 4 squares, 4 rectangles, not squares, excuse me. So there's 3 different regions, that's the denominator, and only one of those regions is the dark blue, 1/3, same as 4/12. Another way to look at fractions is a set model. A set model means we have a set of objects. We have a set of apples. There's 10 apples total. How many have worms in them? Blech. 3 of the apples have a worm. What's worse than biting into an apple and getting a worm? Biting into an apple and getting half a worm. Ugh. So 3/10 of the apples have worms. We can't reduce that because we can't divide 3 and 10 by the same number. So we leave it 3/10. Third way of looking at fractions is fraction strips. This is a unique way, it's the only way pretty much to compare fractions to each other, so it's very powerful. I have a strip here. It's the very same length as the strip of paper down here, and I've colored half this strip dark blue. but I've colored 3/6 of this strip dark blue. I've divided it into 6 equal pieces. That goes on the bottom. And then I colored 3 of them dark blue. 3 goes on top. But look, it's the same length as if I cut that strip in half, 2 pieces, and colored half of it dark blue. That's a way to show students that 1/2 and 3/6 are equal fractions. Very same fraction, just written with different denominators. The fourth way of representing fractions is with a number line. I've taken from 0 to -1 and chopped it into how many pieces? 1, 2, 3, 4 pieces. There's 1, 2, 3, 4 pieces. So the bottom of my fraction will have a 4 on it. And then this is the same length, 1, 2, 3. How many of those little pieces do I have? 1, 2, 3, 4, 5, 6, 7 of those pieces. And because I'm going backwards, it's a -7/4. That's a way of representing fractions on a number line. There's something called the identity property of multiplication, very important for reducing fractions or changing their denominators. If we have a 3/12 and we divide it by 3/3, that's just 1. You can divide something by 1 and still get the same number. I can divide 3 by 1, I'll still get 3. So I can divide 3/12 by 1 and I'll still get 3/12. 3 divided by 3 is 1, 12 divided by 3 is 4. That tells me 1/4 is the same as 3/12, but we prefer the reduced fraction. That's the fundamental law of fractions I just taught you. That you can take a fraction and pull out 1 from it. 4/4, that's 1. What's left if I divide this by 4 and divide this by 4? So I can divide the top and the bottom by 4 and still have the same fraction. 1/6 is the same as 4/24. Here's another property. That means a rule in math. It's very powerful. If you have a fraction and it equals a fraction, here's an example, then you can cross multiply. What happens if I multiply 3 times 4? I get 12. What happens if I multiply 1 times 12? I get 12. This will always work because you're cross multiplying 2 equal fractions. Oops. That's how we can get, you can find a missing number that way. Let's go back to simplifying fractions. I can't divide 7 and 2 by the same number. They have nothing in common. So that's my answer. But I can divide 26 and 39 by the same number. I can divide them both by 13. Divide the top by 13, divide the bottom by 13. I have a more reduced fraction. It's the same as 26/39, but it's simplified, it's reduced. That's how you make fractions in their simplest form. You divide the top by the same number as you divide the bottom, divide the top by 7 and the bottom by 7, and what's left is 1/4. Here's another way to show equivalent fractions. It's by fraction strips. If I have divided this into 6 pieces and 5 are colored dark blue, what if I divide it further into 12 pieces? Then 10 of them are dark blue. 10 of the 12 are dark blue, but I didn't change the length. 5/6 is the same as 10/12. Let's look at the other example. I divided this length into 4 pieces. One of them's dark blue, but if I divide each of those further into 3 smaller but equal pieces, 4 pieces times 3, I have 12 pieces. And the same length would be 3 of the 12 that are dark blue. So 1/4 equals 3/12.